Hi, Assalamualaikum. My name is Nur Alisha Shafi binti Nur Razuli Rahman, and today I'm gonna tell you about Pachymeter. First of all, is a pachymeter refers to a machine that can be used to measure the corneal thickness. The pachymeter map allows for accurate pachymeter reading over broad areas of the cornea, allowing for detection of subclinical thinning suggestive of corneal disorder. In this presentation, you will hear a term of pachymetry. Pachymetry is a term used for a corneal thickness test. Ultrasound or optical technique are used to measure the corneal thickness. This test is important as it helps in diagnosis and management of various eye conditions. Other than that, this test is also an essential indicator of overall corneal health. It is useful for both as a clinical and research tool and is used especially to assess corneal thickness before and after refractive surgery. The normal corneal thickness in human is between 0.7 mm to 0.9 mm at the limbus, while in the center of the cornea, the thickness is 0.49 and 0.56 mm. In this presentation, I would highlight two types of pachymeter, which are ultrasound pachymeter, and which is also known as USP, and also optical coherent tomography, or also can be called as OCT. First of all is an ultrasonic pachymetry. It is a common and quick method of obtaining the corneal thickness on a single point on the cornea. It is an applanation device, which is a method of checking eye pressure that requires anesthetic before use. Therefore, this test should be performed after the slit lamp examination has been completed. It uses a technique of an ultrasound trace, and echo can be seen at each significant corneal interface. So the distance between the epithelial and endothelial echoes, once calibrated, will provide a measurement of corneal thickness that is converted to a digital readout. So it is a most common device and it is classified as a gold standard in measuring corneal thickness. There are three components that can be seen in USP. First one is the probe handle. So this handle have a crystal that emit ultrasonic beam approximately 20 MHz. Next is a transducer, which function in sending ultrasonic wave from probe to the cornea and receive echoes before converted into processed data. Lastly is the tip. So the tip diameter must not more than 2 mm. So this tip will in contact to cornea, give pressure to applanate it. So OCT, what is it? Optical coherence tomography, or OCT, is a non-contact imaging device. It uses a laser scanner to produce 3D tomography image with high resolution. It is used for imaging the anterior segment of the eye, in addition to its more well-known use in retinal image. So the function of the OCT is to examine corneal shape, aid rigid scleral lens fitting, measure and monitor the corneal thickness and curvature, assess tear volume through imaging the tear meniscus, evaluate anterior chamber angles in glaucoma. So there are two types of it, which is the Fourier domain and the time domain. Next, we move to the component of the OCT. So first of all is the light source. A broadband light source with a short coherent length is used for imaging. Next is the beam splitter plate or cube. So beam splitter is to split the light into the reference and sample beams, allow reference beam to be reflected to the reference mirror while the sample beam is focused into the sample using an optical lens. Next is the dielectric optical mirrors. It used to reflect the reference beam to a known path length back into the interference system. Other than that is the optical lens. A standard planar convex used to focus the split beam path into the sample and detector. This lens will focus the light into the sample at a smaller spot size with reduced aberration, making a more precise OCT system. Lastly is the detector. The detector is sensitive to the radiation returning from the sample and reference beam. The principle under this machine is light from a low coherent source is split into two paths by a coupler, directing it along two different arms, which is reference and sample arm of the interferometer. When the light exits the fiber end of either arm, it is shaped by various optical components to control specific beam parameters. In reference arm, the light is back reflected by a reference mirror and it returns into the interference system, propagating along the same path it came from but in the opposite direction. So in the sample arm, the beam is back scattered by the sample. The returning light from both arms recombine at the coupler and generate an interface pattern, which is recorded by the detector. So here are the list of the reference that I use in this presentation. So that's all from me. Thank you. Bye.